Question 6, we are going into circular measure, and in part A, we are given a sector with a center O here, right? And then we are given a arc, which is arc AD, and we have an angle here, which is theta, and it's in radians. Okay, so let us take a note here, it's in radians. And we are given the radius of the sector, which is r units, and the area of the sector, which is a unit squared. So based on this diagram here, we need to show this formula. And this formula is very familiar, right? Because this is the area of the sector formula, which is also one of the formulas in the formula sheet, right? Formula 28. Right, first thing first, let us understand how does sectors being formed, or meaning where does the sectors come from, right? Because we know sectors is a part of a circle, so technically sectors are coming from the circle. Alright, and since we know the formula of area of the circle, right, which is pi r squared, we can use that formula and find back the formula of area of the sector, right? Because sectors come from the circle. Alright, so let us use the formula of area of the circle to find back the formula for area of the sector. Right? But the issue is we don't know what is the relationship between these two formulas, or meaning what is the bridge between these two things, these two formulas. So let us think of this way. From a circle, how can it change it to a sector? Right? So for circles, as we know, the angle is the entire turn here, right? Or meaning one turn. And one turn, we know that it is 360 degrees. But in the question here, we are using radians, so we need to change it to radians, which is 2 pi. Alright? So the angle of the entire circle here is 2 pi. So if we want to change this circle into a sector, we need to change the angle here, or meaning we need to reduce the angle, right? So when we reduce, and let's say now the angle is here, okay, just this part of the angle here, the shape has become a sector, right? So the bridge between sector and circle is the angles. So from the area of a circle, what we need to do is we are going to divide the angle of the entire circle, and we are going to multiply with the angle that we want, which is the angle of the sector. Right? So once we've done this, then we can find out the formula for area of the sector. Right? So now for each of these things, let us find out the expression or the value. Right? So for area of a sector, in the question they already gave us, which is capital A. Right? So I'm going to put this capital A here. And for the angle of the sector, it is also given, right, which is the theta here. Angle of the circle, which is the entire turn or one turn. So we are using radians in this question, right? Radians in this question. So we are going to use 2 pi. And for the area of a circle, we already know it's pi r squared. Okay, so now we have all the expressions for all these 4 things. Let us simplify this equation, right? So for the pi here, I'm going to cross it off. And now basically we have these 3 things, right? The 2, the theta, and r squared, right? So if you combine these 3 things, actually we can prove the formula already, right? Because the 2 below is actually 1 over 2. The r squared here is the r squared here, and theta would be here. And when we combine all of these things, this is actually the formula for area of the sector. And we have proven the formula. For part B, there's a lot of information here, so let us go through one by one, and I'll explain it using this diagram here. Okay, so this diagram actually comes from the diagram in part A just now, right? So if you compare these two diagrams, actually they just added a few lines here and there, right? So let's go through the added lines as well. Alright, so the first two lines they have added is actually from point O, and it draws until it reaches point E, and draw until it reaches point F. Right? So the two new lines are actually OE and OF. Right? And when they are drawing these two lines, right, they will intersect the arc AD as well. So it will produce two more new points, which is point B and point C. Alright, so if we look at this line EF, if we go back to the question here, it says this is an arc. Alright, so this is arc EF, and this arc EF will be using the same center, which is O. And since we know that only sectors have arcs, right? Only sectors have arcs, which means that this shape here, OEF, right? OEF is actually a sector. Because again, sectors only have arcs. Alright? And we are given the radius of this sector, which is 16 cm. So it means that the lines OE and OF would be the radius, and both of them will have a length of 16 cm. Okay? And the next thing given here is actually the arc lengths of AB, BC, and CD are equal, right? Which means the three lines here will have the same length. And this diagram also added another two new lines, which is lines AE and DF, and both of them are actually tangents to the sector here, right? The sector OAD, right? So line AE and line DF here would be the tangents. And here below here we also have another information, which is the length of OA is 12 cm. Right? So OA is actually the radius of this sector OAD, right? And OD is also the radius of this sector, so OD is also 12 cm. Right? So now we need to find out the area of the entire diagram here. Right? So to find out areas, I will always recommend students to use either one of these two ways. So the first way is big shape minus the small shape, and the other one is to add up all the shapes. So in this question here, we are trying to find the area of the entire shape, so we need to use the second way this time. Alright, so you may be asking, what is the first method here? Big shape minus small shape. Okay, let me give you a simple example. So let's say we have this shape. So outside is actually a rectangle, and inside of it is a triangle, and we need to find out the area of the shaded region here. Right? So how are we going to use the big shape minus small shape way to find out the area? Right, so big shape here refers to the recognizable shape that includes the area that we want, which is the shaded region. Right? So the recognizable shape would be the rectangle here. Right? So this would be our big shape because it includes the area that we want. But of course, this cannot be our answer, right? Because it includes the areas that we do not want. So this is where small shape comes in. It is also a recognizable shape that we need to remove from the big shape, or meaning we need to remove the areas or the regions that we do not want, right? So the shape that we do not want is actually this part, which is also the triangle, right? So to find out the area of the shaded region would be the area of the rectangle minus with the area of the triangle. Okay, and then we can find out the area already. Alright, so now coming back to this question here, we are going to use the second method, add up all the shapes. So we need to do two things here. Alright, so the first thing here is to recognize all the shapes in the diagram. And the second thing we need to do is to select the correct formula to find out the areas of each of the shapes here. Okay, so let us use this way, add up all the shapes to find out the area. Right, so the first thing is we are going to recognize all the shapes in this diagram. So just now when we are talking about the arc EF, right, we have mentioned that this entire shape here is actually a sector, right? Because only sectors have arcs. So if we want to find out the area, we first need to find out the area of this sector OEF. Okay, and how about the other parts? So if you look at here, for the shape OAB, this is also actually a sector, right? Because there's an arc here, right? This is an arc. So this one is a sector, but how about AEB? This small part here is not a recognizable shape that we can think of, right? Because it's quite small and the shape is quite, I would say, not recognizable. So how are we going to find out the area of AEB? Okay, if you look outside of the diagram a bit, right? If you look at the entire diagram here, actually if you combine this sector and this small part here, is actually inside the triangle here, right? So we can use area of triangle to help us find out the total area of the sector here and this small part here. Okay, so this same goes to the other side as well, right? Because all of the lengths here are the same. So you see OE and OF is 16, OA and OD is 12, right? And the the arc here, AB, is same as CD. So technically, the triangles OAE and ODF both are actually the same. Okay, so to find out the area, what we need to do is we can find out the area for one of the triangles first. Let's say it's OAE, and we multiply 2. Okay, so we have recognized all the shapes already. Then we can go to the second part, which is select the correct formula to find out the area of sector and the area of triangle. Right, so to find out the area of sector, we can go back to part A, which is the formula that we have proven, right? Which is formula 28, area of a sector, right? So let us use this formula, 1 over 2 r squared theta, right? So 1 over 2, and the r here will be the radius of the sector, which is given, which is 16, and don't forget the square here. And how about the theta? Okay, so the theta, which is the angle of the sector, would be here. Sorry, let me change it to black color. Right here. This is the angle that we need to find, but it's not given here. Alright, so we can look at this information given here. It says that all the arc lengths here are the same. So since all the arc lengths are the same, the angles are the same as well. So all of them are theta. Okay, maybe we can use the triangles here to find out the theta. But the issue is, what kind of triangle is this? Okay, then we need to look back into here. Just now we have mentioned that the line AE and line DF are the tangents. And if we recall back, what we have learned for tangents is, tangents are lines that intersect one point of the circle or the curve. Right? So if you focus on line AE, you can see that it intersects the circle at point A. Alright, but there's another crucial thing that we need to know is tangents and the radius of the circle are actually perpendicular to each other, right? So these two lines, just now we have mentioned that they are the radius of the sector. So the radius and the tangents here are perpendicular, right? They are perpendicular. Okay, so what does this mean for this triangle? This means that this triangle is actually a right angle triangle. And since this is a right angle triangle, if we want to find out the angles, we can use trigonometry. Alright, the sine, the cos, and the tan. Right? So to use trigonometry, what we need to do is to identify for each of the lines here, is it opposite, adjacent, or hypotenuse. Alright, so let's start off with opposite. So opposite is the line which is opposite of this angle. So opposite of this angle would be this line AE. So AE is actually the opposite line. Right? And the other line here would be the adjacent, right? Because this line here is actually the hypotenuse, right? The hypotenuse. Okay, so now since 12 and 16 here are given, so let us use A and H. And which trigo function uses A and H? Cos, right? Because cos is A over H. Right? So let us use cos to find out the angle here. Right? So for the angle here, I'm going to label it as AOE, and we are going to equal with the adjacent, which is 12, over the hypotenuse, which is 16. Okay, and to find out the angle here, we can just move the cos to the other side. So here would be arc cos 12 over 16. Okay, so this is not pronounced as cos power of -1. This is called arc cos, ARC cos. Okay, so if we put this into the calculator, you will find out that the angle is 41.41 degrees. Okay, but remember the formulas for area of the sector and the arc length, both of the thetas here are using the radians. Okay, only these two formulas in the formula sheet uses radians. The other formulas only uses degrees. Okay, let me rewrite this again. Alright, radians. So means that this angle here, we need to change it into radians as well. Right? So to change to radians, quite simple. We are just going to multiply pi and over 180 degrees. Right? But just a note here, for this pi, please use the value given in the question, which is 3.142. Do not use the pi in the calculator. Right? Do not use the pi in the calculator. Right? So if we put this into the calculator, you'll find that the angle is 0.7228 radians. And make sure this is in 4 decimal places. Right? 4 decimal places. Okay, so let us put this angle into our working here, right? So we're going to multiply with the theta or the angle. And to find the area of the triangle, so since OAE is actually a right angle triangle, so the correct formula would be the 1 over 2 times the base times the height formula. Right? So here would be 2 times 1 over 2 times the base would be this line here, OA, and the length is already given, which is 12. And for the height here is line AE, but it's not given here. Alright, but we do have the length of the other two lines in this right angle triangle. So to find the length of one of the lines in a right angle triangle, we can use the Pythagoras theorem. Okay, so let's use Pythagoras theorem to find out the length AE, right? So for Pythagoras theorem, it would be the length of these two lines, OA and AE. We square them, we add them up together, it would be the length of the hypotenuse squared, or OE squared. Okay, so now let us put the lengths that we have inside this equation here. So OE is 16, OA is 12, and now we need to find AE square. Okay, so here for the 12 square, I'm going to move it to the other side, and then I'm going to switch the places. So AE squared will be on the left, and 16 square minus 12 square will be on the right side. Okay, and the square here, right, there's a square here, I will move it to the other side. So here will be a square root 16 square minus 12 square. Right, so the square here, I move it to the other side, but when we move square to the other side, there will always be plus and minus here. Right, but here I ignored the negative one, right, because AE is a length. There is no length which is negative, right? So here we are just going to ignore the negative version of the answer. We are just going to look at the positive version of the answer. Alright, so if we put this into the calculator, you can find out the length AE is square root 112. Right, so let's put this value inside our working here, and we have find out all of the values to find out area of sector and area of the triangle. Right, so once we put this into calculator, we can find out the area is 219.51 cm squared.